Hello everyone, welcome to another kinetic tutoring video. Today we're going to be talking about the inertia of a triangle, so let's get right into the problem. The prompt reads, a piece of thin uniform wire of mass m and length 3b is bent into an equilateral triangle. Find the moment of inertia of the wire triangle about an axis perpendicular to the plane of the triangle and passing through one of its vertices. Alright, so the first step we're going to want to take is to draw a diagram to get a better visual of the situation. So here we have our horizontal axis and here's our vertical axis, and we're going to draw our triangle right here. Now, since the length of the entire wire is 3b and all of the lengths of the triangle sides are the same, we can infer that each one of these side lengths is going to be b. And we also know from this information that all of the angles are going to be the same as well. Now, we're finding the inertia of the triangle around its center of rotation, which is going to be at its centroid. And so in order to do this, we can simply set each side as its own individual rod and then add up the inertia of the three rods at the end to find our total inertia. So we know that the inertia of one thin rod is going to be 1/12 ml squared, but this only applies when the rod is rotating around its center of rotation, which as we can see is not the case, as all of the rods are a certain distance away from the center of rotation. So we can apply the parallel axis theorem here and say that the inertia is going to be 1/12 ml squared plus m times the distance between the center of rotation and the center of the rod, which we're just going to call a squared. So this distance here, and this distance here are all going to be a. Now the next step we're going to want to take is to find a value for a in terms of b. So since this angle is 60 degrees, an angle of 30 degrees will pass through the centroid in this case. And this information is useful because that can help us find this length right here. So let's draw this small triangle. Here we go. Has an angle of 30 degrees and a height a. And since this entire length is going to be b and this length is half of that, we can set this length as b over 2. So from here we're going to use our trig identities to find a in terms of b. So we know that tangent is opposite over adjacent, so tangent of 30 degrees is simply a over b divided by 2. Now we're going to move b over 2 over to the other side and we'll get a in terms of b. And we can simplify this a little bit further because we know that tangent of 30 degrees is simply 1 over root 3. Now, what we're going to want to do here is plug in our value for a in here. So if we're looking for a squared, that'll just be b squared over 2 squared times root 3 squared, which will be b squared over 4 times 3, which is b squared over 12. So our value for a squared is going to be b squared over 12. We'll add these together and keep in mind that our length is simply going to be b, so we'll have 1/12 m b squared plus 1/12 mb squared, which will give us 1/6 mb squared. Let me get rid of this other stuff that we don't need here anymore. Alright, and now that we found the inertia of one rod around the center of rotation, our final step is going to be to multiply this inertia by 3 to account for all 3 of the rods that are rotating around the center. So we'll have 1/6 mb squared times 3, which will give us 1/2 mb squared, which is going to be our inertia of the entire system. Hope this helped, and make sure to tune in later for more physics tutorials.